Mass and energy balance for biosystem. Module 11, Mass flow through ecosystem. Segment 1, Hydrologic cycle. It's me, Lily from School of Life Sciences and Technology, Institute Technology, Bandung. This module consists of a first segment, hydrologic cycle, carbon cycle, nitrogen cycle, and phosphorus cycle. And in this segment, we will focus on hydrologic cycle. Because the biosphere and all its elements are open thermodynamic system, energy moves across these boundaries continuously. However, for all intended purposes, the biosphere is a closed system with relation to mass. And mass move across ecosystem boundaries over times or flux in organic forms and inorganic forms mediated by relatively rapid biological processes and by relatively slow geologic process. The cycling of mass through biotic and abiotic elements of the biosphere is termed as biogeochemical cycling. The predominant components of concern in mass flow through ecosystem are water, carbon, nitrogen, and phosphorus. In hydrologic cycle, water cycles throughout the biosphere as gas, liquid, and solid. The hydrologic cycle is the most ecologically and economically important geochemical process on Earth. And the global atmospheric water balance can be calculated as the equation below, with the W is the precipitable water and WC is liquid and solid water in atmospheric column, and H is the horizontal divergence, Q vectors vertically integrated. If we ignoring solid and liquid phases water in the atmosphere, the relationship can be simplified to the equation below, and the water balance for river system can be represented as equation below. Assuming that atmospheric and basin storage do not change on an annual basis, so the previous equation can be written as the equation below. And for a given basis, water-vapor convergence, or P minus E, is equal to the runoff from the basin over an annual basis. Thus, for a basin, water evaporation can be estimated as the equation below. From this equation, we know that most basins have average annual flow and precipitation data, but evaporation data are difficult to collect and often not available. So this approach can be used to locate annual evaporation across a basin upon land cover, slope, soil type, and other known variables. So for the ecological engineer, we must understand that implication of potential changes to climate and thus weather patterns for the ecosystem surfaces they are designing. For the next segment, we will discuss about the carbon cycle. Until then, I'm Lily from Institute Technology, Bandung.